Today we're going to do decomposition reactions. Now, if you remember, decomposition reactions are reactions similar to a divorce, where we have one compound and it breaks apart into its parts. So one reactant breaks into multiple products. The equation we're doing, the reaction we're doing today is reaction E, which is the decomposition of hydrogen peroxide. You've probably seen hydrogen peroxide in your medicine cabinets. We use it as an antibiotic to kill off the germs if I have a cut or something like that. Now, it's kept in a brown bottle because it naturally decomposes. It naturally sits here and wants to break apart when exposed to sunlight. So we keep it in a brown bottle so that the sun doesn't hit it. But as the sun starts to hit it, every time you open the bottle, close the bottle, it will start to decompose from one reactant into several. So I poured some hydrogen peroxide into here. Currently, right now, it is decomposing. Now, you can't see this reaction, and it's happening at a very, very slow rate. It's decomposing into water and oxygen gas. So right now, water is building up in here, and oxygen gas is coming off as this chemical decomposes. In order to speed that up, we're going to add something called a catalyst. If you read on your paper, a catalyst is strictly to speed up the reaction. It's not involved in the reaction. We don't write it in the reactive equation. So I am just going to add some of this to speed up this reaction. And notice you're starting to see it fizz. What I'm doing is trapping that oxygen gas that's coming off of that. And to prove to you that there's oxygen gas in there, I am actually, I guess you can't see it. It's fizzing up. I'm actually going to prove it with a lit splint. So I'm going to blow this out, stick it in there, and notice how it relit. Blow it out, stick it in there, and it relits. Not sure if you can see that, but what's happening there is the hydrogen peroxide decomposed, produced oxygen gas. I sped it up using the catalyst, manganese dioxide, and I put a lid on it to trap the oxygen gas, and I proved that oxygen was present using that glowing splint that reignited in the presence of oxygen. So that is reaction E. Now we're going to do reaction F, is to use a small amount of sodium hydrogen bicarbonate, or sodium hydrogen carbonate, which is a fancy word for baking soda. So I'm going to take a little bit of baking soda, stick it in my test tube. Notice there's no other chemicals. I'm going to heat it up over my Bunsen burner. And then again, it's very hard for you to see this. I know this, maybe if I stand on this side of it. You are actually, we're going to heat this for a little while. And I don't know that you can see it, but it's getting foggy up here at the top. And I'm starting to see water droplets collect at the top of the test tube. I don't know if you can see that. I don't think you can see it. See the fog at the top of the test tube? That's actually water droplets. As that sodium hydrogen carbonate decomposes, water is coming off of it. So that is reaction F. These aren't really exciting today. And then the last reaction is reaction Z, where it asks you to take a small amount of soda. And let me open this up, hopefully. A small amount of soda. Pour it into a test tube and watch what's happening. Now, you've seen this already. You know what's happening. All the bubbles come up. That is actually a decomposition reaction. Within the soda is Carbonic acid is trapped in the soda, and when we open it up and let the pressure go, we see this decomposition of foam. And you're going to answer the questions in reaction G to figure out what the products of this chemical reaction are. So that was our decomposition lab.